Hello, and welcome to the first tutorial video for ISYE 4140. The purpose of these videos is to supplement the course and act as an additional resource for students. In this video, we will be covering the basics of RStudio and how to get started with the software. First, you'll need to download both R and RStudio. Download and install first from crayon.rstudio.com. The screen should look similar to this, and you'll select the version for your operating system. After you follow the instructions on the download manager for R, you should download RStudio from rstudio.com/products/rstudio/download. Or you can type RStudio into Google, and this link should be one of the first few results that pops up. After downloading and installing RStudio and R, you should go to your Applications folder, or wherever you've saved RStudio, and open the program. You'll see here that both R and RStudio appear. However, in this class we will just be using RStudio to interact with R, as it provides a more user-friendly interface. When you open RStudio, you will see a window similar to this with 4 panes. If you only see 3 panes here, go to File, New File, and click R Script, which will open the 4th pane. The window in the top right is the environment window, which shows you all the variables you are currently using or have defined in this RStudio session. The History tab shows you all the commands you've used in both this session and the previous ones. You can see here, these are the lines of code that I've typed in previous RStudio sessions. Below this is the Files tab pane. This will show you what directory you're currently working in, which I will show you how to change in just a minute. This is also where your graphs and figures will appear, or any information you've requested from RStudio using the help function. To the left of this is the console. This is where you're going to be typing most of your commands and seeing the output. You can also type commands in the window above, or with the RStudio script window, or pane. This window in the top left is for scripts that you want to save. You can write commands here that you know you'll need to run several times without having to retype all the lines of code every time. Let's move on to some basic actions in RStudio. First, as I mentioned just a minute ago, setting the working directory. This will come in handy when you download files from class to work with. To import data files into RStudio, you'll need to tell it where to look for the file first. So go to the top menu and click and select Session, and then Set Working Directory, and from there you'll want to choose what directory. This opens a window where you can select the location of the file or files you want to import. Presumably, most of these are going to be in the Downloads folder. You can see in the Files tab pane on the bottom right that it's now showing me all the files I have currently in my Downloads folder. So we're going to import a sample data file into RStudio. This can be done in several ways, which you can see here. You can use the read.table command for most all types of files, and it requires only one field, the file name with the extension in quotation marks. The next 2 fields, shown here in the second line, are optional. The header field indicates if the first line of the file is a label, which is most often true. The separator field is useful for files like .csv files, where the separator is a comma, or tab delimited files. You can also use the read.csv function, which works in much the same way. For the example dataset we will be working with here, I will use the read.table function. And we're going to set the name of the data file to temp data. You can see here that I'm including the name of the file with the extension inside the quotation marks. And the first line of this file I know is a header, so we're going to mark that field as true and mark that these separators are commas here. And you can see that in the top right, you have a variable named temp data that is a matrix of 99 by 2. And if we ask RStudio to print that out, we can see the same thing. It numbers the rows for you and shows you the headers up here. This data set gives the temperature, the high temperature for a day, and the chance of rain for that day. Note that I made this data up and it's not indicative of any real weather trends, it's just for this example. To get a summary statistics table for this data set, we can use the summary command, which is as simple as it sounds, typing summary and then the name of the data set. And this gives you the minimum, maximum, median, mean, and the quartiles for each column. Of course, it's possible to do this individually, get these values individually. For example, we could get the mean of the temperature column with the mean command, seen here. And what you would do is type the name of the data file and then use a $sign to denote which column you want to analyze. So we'll choose temperature in this case and get 74.76, which you note is the same as the 74.77 up here, just rounded a bit more. So you'll notice that when I type a command like this, a lot of things will pop up that I can scroll down to and choose. And this is a nice feature which helps to reduce possible typos, which would give you a command line error. RStudio offers the usual commands for median, square root, logarithmic functions, exponential functions, sine, cosine, tangent, and so on. If you're unsure about what a function needs in terms of inputs, or which inputs are required and which are optional, you can either type the function into RStudio preceded by a question mark, like so. You can see in the bottom right, the help window will pop up with the name of the function, the purpose or description, and how to use it, including the required arguments and the optional arguments down here. If you're unsure of a function name, you can search Google or go to the help window here and search in the toolbar up here at the top. If you come across a function that you need but do not have the library installed for, you can install the library using install.packages command. For example, if we wanted to calculate the skewness of our data set, I would type skewness and then temp data, and then let's say we want for the temperature field. But it can't find the function skewness, even though we know this is definitely something RStudio is able to calculate. So we'll type skewness here and wait. And you can see here the skewness of the sample function. This function is in the moments package, which is not automatically installed. So now we want to install the moments package using install.packages. And again, moments must be in quotation marks. And it'll take just a minute to pop up with the installation confirmation, like so. And now, since you've installed it, you must load it using library. Again, moments in quotation marks. It does not say anything after this command, but now if we type skewness of temperature, we get a value of negative 0.27. So if you're ever unsure of a function in RStudio or a package, the help search is a great feature to use. There's also plenty of blogs and books, and of course your class materials to reference. Another thing you'll be doing in RStudio is to make graphs and figures to accompany your data. To do this, you'll primarily be using the hist command and the plot command. As you might have guessed, the hist command is used to make histograms or frequency diagrams, while the plot command is used to make basic scatter plots and trend lines. To create a basic histogram here, showing the frequency of the temperatures, we would use the hist command to tell RStudio to look at the temperature column with a title or main of temperature frequencies, and then we can use the X label as temperatures and a Y label of frequencies, and this will just show how often a temperature appears in this data set. And again, this pops up in the Plots tab. So as we can see, this is a pretty basic histogram. It specifies for you the intervals that it breaks your data into. There are ways to set that yourself, but most of the time theirs will be sufficient. However, this is not the best graph for this data set, so let's try a scatter plot to look at any possible correlation between temperature and the chance of rain. So to do this, we'll use the plot command. Again, we will start with the temperature field, and then we want to plot that against the chance of rain field. An X label of temp and a Y label of rain. So as you can see, there's not an obvious correlation between the two variables that we can see from this scatter plot. So to get an actual number, we'll use the correlation function of RStudio, which is just COR and the two fields that you would like to see a correlation between. So we will first plot temperature and then the chance of rain. And this shows that there's negative 0.417 correlation, which is somewhat negative. It's a mild negative correlation. These are some of the basic functions you'll be using most often in RStudio, but certainly not a comprehensive list. There are many tools available to you in addition to these videos, as I mentioned previously, including RStudio blogs, books, and of course your class materials and professor.